All right, and now we are on the 2021 AMC 10A problem 21. Let a backdef, which is another way to say A, B, C, D, E, F, be an equal angular hexagon. The lines A, B, C, D, and E, F determine a triangle. Okay, so first thing, equal angular? Why don't they say regular? Because it's not regular. And so we're going to have to try to make some kind of equal angular hexagon. My initial assumption is that it's going to have three sides equal and the other three sides equal to something different, mostly because there's been a problem like that before on the AMC 10. I'm going to first use that assumption and then try to confirm that it's okay to use it. So I'm going to have a smaller side here, and then we will go, maybe I should go a little bit lower on the board just in case I need the space. So small side here. And then at 120 degrees, the equal angular is going to be 120 degrees for each angle. You can get that because you can do 360 divided by 6 is 60, which would be each of the exterior angles. And then you would know the interior angle has to be 120, because the exterior angles of any convex n-gon always add to 360, and there's 6 of them, and they're all going to be equal because the inside angles are equal. Okay. So 120 degrees, I don't know, 90 would be here, so maybe like something like this. And we'll go a little bit longer, and then like this, again longer. And then what? Then we're going to go up. We've got three sides right now, so try and do one just like this, about 120 degrees. Actually, not quite there, not vertical. It's going to be more like at 90, like this kind of. Yeah, like that. And like that. And again, we're trying to draw these two so that they look like this one and then this one over here. Maybe it should be more like that. This one over here like that. Okay, almost, I guess that's like Superman symbol. Okay, so this is A, B, C, D, E, F. I don't know if that's going to work, but we're going to try it just like that. All right, so the lines AB, meaning if I extend AB, okay, I extend AB out, I extend CD out, they're going to meet at a point. And AB out this way, and EF out this way, and EF out this way, are all going to meet at points. Okay, great. And so it says AB, CD, and EF, they all meet there. That's a triangle with area 192 root 3. So I think what we're going to do is we can't call it just 1 for something because we do have a specific area we have to achieve. Let's just say that this is X and Y and Y and Y. Y. Other one would be Y up here and the X here. So the thing is, we already said what the exterior angle was. It was 60. So we know that this is 60 and this is 60, which means this is 60, and that's an equilateral triangle. So then these will all be the same size, but since all of the corner angles are 60, that big triangle that we created, it's equilateral. And that means, under my current assumption, which we'll think about more in a minute, this is X plus 2Y is the side length. So you should be able to recall that the area of an equilateral triangle is S squared root 3 over 4. Okay, so since this is the side length of that big equilateral triangle, it squared times root 3 over 4 is going to have to equal 192 root 3. Okay. What next? All right, so then we're going to keep going. The other ones also we're going to extend. BC, DE. DE was these 2 points. So when I extend DE out, they're going to meet and make a 60-degree angle just like that one did. These ones are not the same size as the others. Okay, but it will be equilateral just like that. And since this is X, this will be X and X and X and X. So we've got 2X plus Y is the side length of that one. So we can say 2X plus Y squared root 3 over 4 equals 324 root 3. And so Based on that, now we want to think the perimeter of hexagon ABCDEF. Well, what is the perimeter of our hexagon? It was 3x plus 3y. Okay, so we're looking for that. I kind of like to write things down I'm looking for, so in case I come across it sometime when I'm solving, it's right there to look at and confirm that's what I need. Can be expressed as m plus n root p, or radical p, where m, n, and p are positive integers, and p is not, basically you can't simplify it. What is m plus n plus p? So find this and make sure it's fully simplified, and then add up the numbers that make up the expression m, n, and p. Okay, so now we have to pay the piper. We got to figure out, is the assumption I made okay? Here's the deal. If we get an answer with this setup and it works, and we didn't violate any of the rules expressed, that answer must be accepted. Even if there was a different way to set it up, the answers they produce could not be different. Why? Because the question would be invalid. There would be more than one correct answer. So even though we made an assumption, it's a safe assumption to make, and we can solve the problem as if that was the case. Even if there was another way, both ways must lead to the same answer. Again, as long as we didn't violate anything, and we haven't, this should work out. So let's try this out now. What I see right away is the root 3's and the root 3's can cancel here and here. I see something squared, 324, wow, we should know what that is. That's 18 squared, and this is 2 squared. So altogether, that's going to be 36 squared. So I will have 2x plus y squared equals 36 squared, right? It's 18 squared times 2 squared, which is 36 squared. Square root, get 36, win a prize. 2x plus y will now equal 36. Okay, let's do this one. 4 times 192. So we're going to get x plus 2y squared equals 4 times 192. We got rid of the root 3's if you recall. All right, now you could multiply this, but why would you do a thing like that? In fact, that's a general principle. Never multiply anything until you have to. Just don't. There's probably a way to capitalize on that non-multiplication later. And 192, that looks familiar. It's divisible by 48. So it's 4 times 48, and 48 is 16 times 3. So we would have 16 times 4 is 64 times 3. Okay, so altogether, this is going to be 4 times 64 times 3. Does that make sense? And now we're going to square root. Why did I rearrange it like that? Because those are perfect squares. And you're going to get x plus 2y is going to equal, the square root of this is 2, the square root of 64 is 8. You're going to get 16 root 3. And for a second you're like, but wait, I've got to square. Oh, they want to square something. So this is probably fine. We're fine, right? So all we're going to do now is add these together. Wait a minute, 3x, 3, that's what we're looking for. This is the answer. It's 36 plus 16 root 3. You can't simplify the 3 in the square root. 36 and 62 is 52 plus 3, 55. Done with 21. See you on the next problem.